Class 6.
Chapter 5 Elementary Shapes. Introduction 5.1. All the shapes we see around us are formed using curves or lines. We can see corners, edges, planes, open curves and closed curves in our surroundings. We organize them into line segments, angles, triangles, polygons and circles. We find that they have different sizes and measures. Let us now try to develop tools to compare their sizes. (5.2) Measuring line segments. We have drawn and seen so many line segments. A triangle is made of 3, a quadrilateral of 4 line segments. A line segment is a fixed portion of a line. This makes it possible to measure a line segment. This measure of each line segment is a unique number called its length. We use this idea to compare line segments. To compare any two line segments, we find a relation between their lengths. This can be done in several ways. (1) Comparison by observation. By just looking at them, can you tell which one is longer? You can see that line segment AB is longer. But you cannot always be sure about your usual judgment. For example, look at the adjoining segments. The difference in lengths between these two may not be obvious. This makes other ways of comparing necessary. In this adjacent figure, segment AB and segment PQ have the same lengths. This is not quite obvious. So we need better methods of comparing line segments. We have another figure with AB and PQ as the different segments. Two, comparison by tracing. To compare segments AB and CD, we use a tracing paper trace segment CD and place the traced segment on segment AB. Can you decide now which one among segments AB and CD is longer? The method depends upon the accuracy in tracing the line segment. Moreover, if you want to compare with another length, you have to trace another line segment. This is difficult, and you cannot trace the lengths every time you want to compare them. Three, comparison using ruler and a divider. Have you seen or can you recognize all the instruments in your instrument box? Among other things, you have a ruler and a divider. We have the pictures of ruler and divider given here. Note how the ruler is marked along one of its edges. It is divided into 15 parts. Each of these 15 parts is of length 1 centimeter. Each centimeter is divided into 10 subparts. Each subpart of the division of a centimeter is 1 millimeter. One millimeter is 0.1 centimeter. 2 millimeters is 0.2 centimeters, and so on. .3 centimeters will mean 2 centimeters and 3 millimeters. How many millimeters make 1 centimeter? Since 1 centimeter is equal to 10 millimeters, how will we write 2 centimeters? 3 millimeters? What do we mean by 7.7 centimeters? Place the zero mark of the ruler at A. Read the mark against B. This gives the length of segment AB. Suppose the length is 5.8 centimeters. We may write length AB is equal to 5.8 centimeters. Or more simply as AB is equal to 5.8 centimeters. There is room for errors even in this procedure. The thickness of the ruler may cause difficulties in reading off the marks on it. Think, discuss and write. One. What other errors and difficulties might we face? Two. What kind of errors can occur if viewing the mark on the ruler is not proper? How can one avoid it? Positioning error. To get correct measure, the eye should be correctly positioned, just vertically above the mark. Otherwise, errors can happen due to angular viewing. Can we avoid this problem? Is there a better way? Let us use the divider to measure length. Open the divider. Place the end point of one of its arms at A and the end point of the second arm at B. Taking care that opening of the divider is not disturbed. Lift the divider and place it on the ruler. Ensure that one end point is at the 0 mark of the ruler. Now read the mark against the other end point. Try these. 1. Take any postcard. Use the above technique to measure its two adjacent sides. Two. Select any three objects having a flat top. Measure all sides of the top using a divider and a ruler. Exercise 5.1. 1. What is the disadvantage in comparing line segments by mere observation? Two. Why is it better to use a divider than a ruler while measuring the length of a line segment? Three. Draw any line segment, say AB. Take any point C lying in between A and B. Measure the lengths of AB, BC, and AC. Is AB equal to AC plus CB? Note, if A, B, C are any 3 points on a line such that AC plus CB is equal to AB, then we can be sure that C lies between A and B. Page 89. 4. If A, B, C are 3 points on a line such that AB is equal to 5 centimeters, BC is equal to 3 centimeters, and AC is equal to 8 centimeters, which one of them lies between the other two? Five. Verify whether D is the midpoint of segment AG. We have the segment AG shown here, and we have some other points marked by B, C, D, E, and F. 6. If B is the midpoint of segment AC and C is the midpoint of segment BD, where ABCD lie on a straight line, say why AB is equal to CD. Seven. Draw 5 triangles and measure their sides. Check in each case if the sum of the lengths of any two sides is always less than the third side. Five point 3. Angles, right and straight. You have heard of directions in geography. We know that China is to the north of India, Sri Lanka is to the south. We also know that sun rises in the east and sets in the west. There are 4 main directions. They are north, N, south, S, east, E, and west, W. Do you know which direction is opposite to north? Which direction is opposite to west? Just recollect what you know already. We now use this knowledge to learn a few properties about angles. Stand facing north. Do this. Turn clockwise to east. We say you have turned through a right angle. Follow this by a right angle turn clockwise. You now face south. If you turn by a right angle in the anti-clockwise direction, which direction will you face? Study the following positions. You stand facing north. By a right angle turn clockwise, you now face east. The fourth diagram tells us by another right angle turn, you finally face south. From facing north to facing south, you have turned by 2 right angles. Is not this the same as a single turn by 2 right angles? The turn from north to east is by a right angle. The turn from north to south is by 2 right angles. It is called a straight angle. And S is a straight line. The figure next to this shows the same. Stand facing south. Turn by a straight angle. Which direction do you face now? You face north. To turn from north to south, you took a straight angle turn. Again, to turn from south to north, you took another straight angle turn in the same direction. Thus, turning by 2 straight angles, you reach your original position.